Hello everybody, welcome back to Anantha Lakshmi Academy. I am Anantha Lakshmi. If you are a new visitor to Anantha Lakshmi Academy, please do subscribe to Anantha Lakshmi Academy. And today we are going to discuss the theorems 9.1 and 9.2 of tangents and secants to a circle. Even before this, we have covered the concepts that are needed for us to understand the terminology that is there in this chapter. Alright, we have also discussed exercise problems even before this. So, as the theorem is already written on the board, let's get started with the theorem statement first. Alright, so what is given? The tangent at any point of a circle. The tangent at any point of a circle is perpendicular to the radius through the point of contact. Alright, so what is given for us? For us, it is given that a tangent is there, a circle is there, okay, radius is there, and a point of contact is there. Okay, so let us draw a circle with a center and a tangent and a point of contact. So what is given for us? All this is given for us. So a circle with the center O and AB is the tangent with point of contact P. Point of contact is P. So what are we supposed to prove now? Tangent at any point of a circle AB is perpendicular to the radius. What is this radius? OP is nothing but radius, no? So we are supposed to prove that. Required to prove. What is that? OP is perpendicular to AB. So let us jump into the proof section. How do we prove that OP is perpendicular to AB? So let us consider a point Q, say on line AB outside the circle, because if we draw any point inside the circle, that becomes a secant, not a tangent. So let me join OQ. Okay, so proof. Let us locate a point Q outside the circle on AB. Observe the length of OQ. What is the length of OQ? Definitely longer than OP, because this looks like this. Which one is longer? This one or this one? This one is shorter. This is longer. So OQ is longer than OP. Now, if I try locating a point here, the same thing here, the same thing here, anywhere other than the point of contact, all the points that this happens for all the points on AB other than at the point of contact. Because at the point of contact you already have this length, the short length. Other than that, rest of the lengths are longer. So now, what is the shortest length that could be drawn from a point to a line? Is nothing but the perpendicular. Okay, the shortest length that could be drawn from a point to a line is nothing but perpendicular. Hence, OP is perpendicular to AB. Nothing but the radius is perpendicular to AB. Let us write the same. Therefore, the shortest length that could be drawn from a point to a line is perpendicular. That implies OP is perpendicular to AB. So the radius is perpendicular to AB. That implies the tangent is perpendicular to the radius, or the radius is perpendicular to tangent. Hence, proved. Alright, that is about the theorem 9.1. What did we do? Whatever is given, we just draw it in the form of a diagram, and then we tried figuring out other than this point, whatever are the lengths that we could, we tried figuring them out, but we figured that all the lengths are longer than this one. So the shortest distance is nothing but the perpendicular, hence that is perpendicular to the tangent. That is how we have proved. Simple, no? Let us look at the next theorem. So let us look at the theorem 9.2. The length of the tangents drawn from an external point to a circle are equal. Okay. What is given for us? Look at the statement. The length of the tangents drawn from an external point to a circle are equal. So a circle is given. From a point, from an external point, two tangents are drawn. Okay. Let it be P, let this be A, let this be B. Okay, let me join sorry, I cannot join it like this. OA, OB. Okay, let me also join OP. Okay, even before this, let me write down the what is given. A circle with center O and let PA and PB be the tangents from external point P. Now, what are we supposed to prove? RTP required to prove. What are we supposed to prove? PA is equal to PB. Let's jump into the proof section. What did we do? We just joined OA and OB. We know that OA is a radius, OB is radius. Nothing but from the center to any point on the circle is radius. And we just figured out from theorem 9.1 that radius makes a right angle with the point of contact. Isn't it? So let us write the same. Join OA, OB and OP. Okay. OA is equal to, OB is equal to what? The radius. Isn't it? Now, what is angle OAP? Similarly, angle OAP is equal to, angle OBP is equal to how much? 90 degrees. Now let us look at these two triangles, the upper triangle and the lower triangle. So consider the triangle in triangle OAP and OBP. So what is equal? These two are radius, right? So OA is equal to OB and OP is equal to OP, as that is a common side. So OP is equal to OP. Now two sides are equal and an angle OAP is equal to angle OBP, which is a right angle. Now two sides are equal and an angle is equal. Now this is nothing but two sides and an angle. Let's say yes, congruency. We can say that the two triangles are similar. That implies triangle OAP is similar to triangle OBP. Now, when we say that two triangles are similar, what can we say? That sides are equal. So, what is the side? PA and PB are equal. That is nothing but which implies PA is equal to PB. Is that what we are supposed to prove? Yes. Hence, proved. Alright. So what did we do? We just draw two tangents from an external point and we joined the center and the point of contacts, which resulted in right angles, and later we joined the distance from the center to the external point. That became the common side for these two triangles, and one angle is equal, and two sides are equal. Hence, we said that the triangles are similar, and by that we mentioned that the sides will become equal, and that's how we prove this theorem. Alright, so that is about this video. I'm gonna close this video here with these two theorems itself. Later in the next video, we will be coming up with the statements that are there in your textbook. So till then, keep watching Anantha Lakshmi Academy, and if you like the content, please do like, share and subscribe to Anantha Lakshmi Academy. Also, please refer this to your friends or any of your relatives who are studying in 10th class. Thank you for watching.